Yes, hello, my name is Rostyslav. I'm gonna talk about introduction to the ranges library. You can find me on LinkedIn. Yeah, there I post mainly about Ukraine because it's my home country and it's fighting for its survival. But you can also find me on GitHub. I'm Byte Bunny there, and you can grab a copy of these slides there, if not for the content, just for the list of references that I use preparing. These are very good resources, in my opinion. And before we start, by the show of hands, who is using ranges library? Maybe a third. Who is not using? Maybe 2/3. And who is not using anymore? Nobody. Maybe one. All right. So the ranges library, what is it? It's a new library starting from C++20, and it did evolve in C++23. It is based on Eric Niebler's range v3. So if your compiler is not capable of C++20, but is capable of C++14, you can do most of it that ranges offer. It is an abstraction layer on top of iterators. And it extends the STL to make iterators and algorithms composable. And we will see what that means when we come to the views. So what is a range? Range is defined as a concept, and it's another C++20 feature that allows us to constrain the template parameters. So this, if you're not familiar with concepts, this just says that it is required from a type T to provide a begin and end functions. And begin returns an iterator type, and end can return a sentinel type. And the sentinel is something to mark the end of the collection. So it does not have all the features of an iterator. So that's it. That's how it is defined. You can actually, this is more or less the exact code, except for the standard uses it or the compiler implementation uses this weird underscore. Yeah, but this is exactly what you can find in your header if you look there. So that's your range. What are the examples? All the containers, these are ranges. They all offer begin and end. So the array, the string, the deck, the map, so on. The container adapters are also ranges. And views, like string view, span, and other views that we will see. These are all ranges. So what does it bring us? What do ranges give us? So they are derived from STL algorithms, but better. They do eager evaluation as opposed to lazy evaluation. Maybe you've heard about, and we will talk about lazy evaluation when we come to the views. They added the projection argument, which we will see shortly. They are specified with concepts, and that means that you get better error messages. Because, yeah, maybe you know that templates are notorious for humongous error messages that are difficult to parse. And then they improved return types for some of the algorithms. So you would typically get a struct with an iterator and some information. Let's look what is this projection enhancement. So let's say we have a data type called person, which holds a name and an age of a person. And then we have a collection called people of Carl, Glenn, and Ada. So if we would like to sort this collection by age, so with the STL version of sort, you would do something similar to this. You will do a lambda, and then you will do a comparison that has to evaluate to true or false, right? This is a little bit verbose, isn't it? Just to say that, hey, please look at the age of this data type. So with ranges, what you can do is to just say, like the third parameter is the projection. So you say, I want you to consider, when you sort, I want you to just consider this. So maybe you know this empty brace. What is that about? Okay, let's look at one of the signatures of this range sort. And so you see it's a template on the random access range, which is a concept. Again, this is one of the ways there are multiple ways to require or to constrain your data type with the concepts, and this is one of them. So instead of data type, you say this is a concept, so this is random access range that I need. The second template argument is the comparator. Yeah, so this is predicate, which defaults to less. Yeah, so just less than then. And the third argument is the projection, and it defaults to identity, which you can think about as the identity matrix, if you remember your linear algebra. And I think it's implemented just like as an overload. It has an operator, the call operator, and it returns whatever it gets. Yeah? So what gets in goes out. Yes. And then, so what we require is that it's for the given comparator and the projection, this iterator type has to be sortable. Right. And so what the projection does is it maps a set into a subset. And furthermore, we can notice that the ranges version of sort, it gives you something back, and it's an iterator type. Why is that useful? Well, let's say you have a collection of numbers and you want to sort a portion of it. So we do begin and then begin plus 5. And what you get is the end of the sorted collection. So then you can create this stud span and get your sorted portion of that collection. Continuing with the return values, the stud min-max in the STL version was returning a tuple, or a pair, now I don't remember. Which gives you this outcome. So let's say you call it, you get the result, then there is a bunch of code, and then you need to use it. So what you get to work with is this first and second. So you have to remember which one is which. But with the ranges version, what you get is the meaningful names. So they represent the actual result. Yes. So that was the uncontroversial part of the library. Now we come to the little bit more complicated part. So what is a view? That is, again, a concept. And now we see it's a constellation of things. But we can summarize this as a type, as a range type, that is cheap to move, copy, if it's copyable, assign, and destroy. And it's lazily evaluated. And the consequence of that is that if you have constructed your view as a collection, because we said it's going to be composable, so maybe you have a composition of operations and you want to iterate multiple times over your collection, then these steps that you compose it from, they're going to be repeated. We will see that again. So this composing the operations business. So let's say you have a string that represents a path, and you want to extract the last part of it after the last slash. So the ranges introduced a new algorithm called FindLast. So you can look for the last slash, and you can pipe it, just like in your shell, you can pipe this, well, the sub-range then into something called views drop, and we say we drop 1. And what it gives us is that it drops 1 element, yeah, from the front then. So when it prints is just this last part file. All right, what if it doesn't have any slashes? It still works. And look at how it looks. It's very much in this paradigm of functional programming. We don't focus on how we do things, we focus on what we want to do. So that's nice. That's the nice part of it, I find. And then, yeah, so there are no loops, no off by 1 errors. And this views drop, that's called a range adapter. And what they do is they convert ranges into views. Yes. Now we come to this lazy evaluation. Let's say we have a collection and we want to find the even numbers, or only the even numbers in that collection. So we create a lambda that tells us if it's even or not, and we create a filter view. And we say, okay, here is the collection, here is the predicate. So when you create that filter view, the computation that will happen when you create is that it will go through each element from the beginning. It will take 1. Is 1 an even element? No. It will go to the next one until it finds. It can go through the whole thing if it doesn't find what it is looking for. But we find it. 2 fulfills the predicate. Good, we stop there. Now we shove it into print, and that's what drives the iteration. So from that moment on, we will continue. And then if you want to reuse this again, the even nums filter view, this will happen from 2 again. Yeah, so that will be cached inside of the view. So what do? You want to iterate multiple times. You don't want to repeat the computation. Well, you put it into a container. Let's say we have this table that has some characters and some, well, sequences of numbers. So if we want to take these values from that map into a container, then without ranges we would do something like, okay, there is a vector of ints, give me the keys, give me the values, I put the values only, right? Again, this is how we do it, not what we want to do. So in C++ 23 you have ranges2 utility, and you have the views values, so you get a view over all of the values in your map. And then you pass it on to this 2, and it creates a collection for you. So V is vector of ints again. And notice how you don't have to say what it is that what is the data type, right? It will deduce itself that it's a vector of ints that it puts into a vector. I just have to say it's a vector. I could have said it's a deck, and it would be deck of vector of ints. Now the problems. There are problems with this library. So we saw this before. We have a collection. We want to find the even numbers. Okay, we found them. Now we want to iterate them. You are allowed to do this. You can go through your view and modify the data that you view. And that's the undefined behavior if you violate the predicate. So now you have to be careful in how you use it. And there are more problems with it, and I encourage you, if you haven't seen it yet, so Nikolai Yusutis, he had a great talk about this. There are problems with concurrency as well. You can find more pitfalls there. And that's the end of it. Here is the list of references that I used, and as I said, you can find the slides and these links on GitHub. Thank you.